Hi, this video I'm going to tell about the deadlocks. So what is meant by deadlock is I will tell by using one example. Assume that we have two process. So for this diagram, we have two process P1 and P2. These are the two process, and we have two resources. So resource names are R1 and R2. When P1 is here in this example, P1 is requesting resource R2, but R2 is held by process P2. Similarly, the process P2 is requesting the resource R1, but R1 is held by process P1. So in this case, P1 is waiting for the resource R2, and P2 is waiting for the resource R1. So this situation is called as deadlock. Okay, I repeat again. So we have two processes P1 and P2 and two resources R1 and R2. So P1 is requesting resource R2, but that is held by P2. Similarly, P2 is requesting the resource R1, so R1 is held by P1. So both processes are waiting for uh, their resources, but that is held by other process. So this situation is called as a deadlock. So this is actually indication. So what is the indication here is P1. P is requesting R. So this is called as requested, and allocated means R is allocated to P. Okay, this situation is called as allocation. So now we are going to see about the system model. So assume that the system consisting of resources. So what is meant by resources means we have CPU cycles, memory space, I/O devices. So these are all the various resources. Resource types actually we call it as R1, R2, and up to RM. Each resource type have WI instance. So instance means, for example, CPU cycle. We have 3 cycle means we may call it as 1, 2, 3. Similarly, we may have n number of memory space or n number of I/O devices. So that will be called as instances. So we have 3 states are there. Each process utilize the resource as follows. One is a request, and other one is a use, and the third one is a release. So as we see in the previous slide, so here the process P is requesting the resource R. This is actually called as a request state. Similarly, releasing after using the particular resource, it may release the resource. For example, here P is R is allocated to resource P. Once it is completed the process, it releases the resource R. Okay, that is called as releasing the resource. And the other one is using the particular resource. Once the resource is allocated to the particular process, the process may use the resource. That is called as use state. This is actually the system model. So when we may get the deadlock. So deadlock can arise if these 4 conditions hold simultaneously. Simultaneously, if these 4 conditions hold means then there is a possibility of deadlock. Deadlock may arise. What are the 4 situation is 4 condition is mutual exclusion, hold and wait, no preemption, and circular wait. These are the 4 conditions. So I'll tell one by one. What is meant by mutual exclusion? Only one process at a time can use the resource. So this is actually called as mutual exclusion. For example, assume that we have one printer is available. So printer is one of the resource. So at the same time, only one process can use the printer at the same time. So if any 2 processes trying to access the printer at the same time, then you may get the possibility of deadlock. So this is actually called as mutual exclusion condition. Second condition is hold and wait. So what is hold and wait is the process is already holding at least one resource, is waiting to acquire additional resource held by other process. So this is actually called as hold and wait. For example, assume that we have 2 processes, so P1 and P2. P1 is already holding one resource, but it is waiting to acquire additional resource. In that case, you may have the possibility of deadlock. So that situation is called as hold and wait. So hold and wait means the process is holding at least one resource, is waiting to acquire additional resource, that is held by other process. This is actually, this situation is called as hold and wait. And third condition is no preemption. So what is meant by no preemption means the resource can be released only voluntarily by the process holding it after that process has completed its task. Once the resource is allocated to the particular process, only after completing the process it may release the resource. So that is called as no preemption. And fourth condition is circular wait. So circular wait means assume that we have n number of process starting from P0, P1 up to Pn. P0 is waiting for a resource that is held by P1. So again P1 is waiting for the resource that is held by P2. Up to that Pn-1 is waiting for the resource that is held by Pn. So in that case you may have a circular wait. So all the time any one process is waiting for some other resource that is held by other process. So this is actually called a circular wait. So if these four conditions are held simultaneously, then there may be a possibility of deadlock. So now we will see how we can find out the deadlock by using the resource allocation graph. So assume that we have set of vertices V and set of edges E. Okay, V is partitioned into two types. As we discussed already, we have P. So P means it is a process. Assume that we have n number of process, P1, P2 up to Pn. And R means it is a resource, resource type R1, R2 up to Rm. And we have two edges are available. What are the two edges we have is, one is a request edge. So what is mean by that is we have request edge. So this is a request edge and other one is a assignment edge. So request edge means assume that P is waiting for requesting a resource R. Okay, so Pi. So here Pi means it is a process name. So process Pi is requesting the resource Rj. Okay, this is actually called as request edge. Assignment edge. What is meant by assignment edge means the particular resource is allocated to the process. So Rj is allocated to the process Pi. Okay, resource Rj is allocated to the process Pi. This is actually called as assignment edge. And these are the explanation. So assume that here we have one process. This is actually process resource type with 4 instance. So we got 4 square is there here. Inside the square we got 4 resource instances. So this is 1, 2, 3 and 4. 4 instances. And this is actually called as requested. So Pi is requesting the Rj. Okay, so this resource type have 4 instances. And this one is assignment edge. So here this particular instance is allocated to the Pi. One instance of Rj is allocated to the process Pi. This is actually Pi is holding an instance Rj. Now here we have an example for the resource allocation graph. So in this diagram we have 3 processes. What are the process we have is P1, P2 and P3. So these are the 3 processes. And we have 4 resources R1, R2, R3 and R4. So R1 we got 1 instance, R2 we got 2 instance, R3 we got 1 instance and R4 we got 3 instance. Now what is the meaning of this diagram is P1 is requesting resource R1 and this is a request edge and this is an assignment edge. So R1 is allocated to P2 and again P2 is requesting R3 and R3 is allocated to P3 and again here R2 is allocated, one instance of R2 is allocated to P1 and one instance of R2 is allocated to P2. This is an example for the resource allocation graph. Now we got this diagram have a deadlock. How we got the deadlock is, so P1 is requesting R1. Okay, so P1 is requesting R1 and that resource is allocated to already P2, and P2 is requesting R3, but R3 is allocated to P3. Again, P3 is requesting R2, but R2 is allocated to P2 as well as P1. So we have a circle. Okay, we got a circle here. Okay, so graph, any resource allocation graph that contains a cycle, so that is actually called as a deadlock. So in this diagram, so what is a cycle we have is P1. So P1 to R1. So P1 to R1, and R1 is already allocated to P2. So P1 to R1. So then we have R1 is allocated to P2. Okay. So R1 is allocated to P2. Then again P2 is requesting R3, and R3 is allocated to P3. R3 is allocated to P3. Okay, so R3 is allocated to P3. Again, P3 is requesting R2, but R2 is allocated to P1. Okay, now we have a edge, that we have a cycle. Okay, so when the resource allocation graph contains a cycle, it is called as deadlock. Okay, so next diagram. Okay, suppose if the resource allocation graph contains a cycle, it is not necessary that we have a deadlock. There may be a deadlock or there may not be a deadlock. So in this diagram, we have a deadlock. But here, graph again with a cycle, but we don't get deadlock here. Okay, so what are the basic facts here is, if the graph contains no cycles, then there is no deadlock. There is a resource allocation graph. If the resource allocation graph contains no cycles, then there is no possibility of deadlock. No deadlock is there. If the graph contains a cycle, okay, then both the possibilities are there. There may be a deadlock or there may not be a deadlock. Suppose if only one instance per resource type, then deadlock may occur. Suppose if there are several instances per resource type, then the possibility of deadlock. So how to handle the deadlock? There are methods are there. Ensure that system will never enter a deadlock state. Okay, that is a first step. That is, a system will never enter a deadlock state. Second thing is, that is called as deadlock prevention. Second one is allow the system to enter the deadlock state, then recover. That is actually called as deadlock avoidance. Okay, so that's all about it.